In 1963, people stood on sidewalks in New York City just to hear a car start. Not a Ferrari, not a Hemi, not some screaming big block drag monster. This thing sounded like an airplane. A smooth, high-pitched whistle echoed through the streets as bronze-colored coupes rolled silently past crowds who had absolutely no idea what they were looking at. Kids pointed. Mechanics laughed. Engineers stared in disbelief, because under the hood of that strange-looking machine was no piston engine at all. No camshaft, no valves, no connecting rods. Just a spinning turbine turning at over 44,000 RPM. And for one brief moment, Chrysler believed this machine could replace every gasoline engine in America. But what almost nobody knows is how close they actually came. Because hidden behind the futuristic styling and the public excitement was one of the most ambitious engineering gambles Detroit had ever attempted. A gamble that nearly rewrote muscle car history forever. And then, it vanished. Most people think the muscle car era was all about bigger V8s, bigger carburetors, bigger burnouts. But Chrysler was secretly chasing something completely different. Something radical. Something that sounded like the future. To understand how insane this project really was, you have to go back to the late 1940s. America had just won World War II. Jet aircraft were transforming aviation overnight. Turbine engines were suddenly everywhere. They were smooth, compact, powerful, and shockingly simple compared to piston aircraft engines. And Chrysler engineers became obsessed. One man in particular couldn't stop thinking about it. George Hubner Jr., head of Chrysler's turbine program. He believed turbines weren't just the future of airplanes. He thought they could power cars too. Hubner wasn't some dreamer sketching fantasies on napkins. He was a hardcore engineer who'd spent years working on aircraft power plants during the war. He watched B-29 bombers roar overhead with massive radial engines. Then he saw the first jets scream past at speeds those piston engines could never touch. And he asked himself one simple question: why not cars? His colleagues thought he was crazy. Corporate executives dismissed it as expensive fantasy. But Hubner kept pushing. He ran calculations. He built models. He presented data showing that turbine technology could theoretically outlast any piston engine ever made. And honestly, on paper, it made perfect sense. A traditional V8 had hundreds of moving parts. Pistons flying up and down thousands of times per minute. Valve springs, push rods, lifters, timing chains, crankshafts, oil pumps. A turbine engine? It had roughly 1/5 as many moving parts, no reciprocating mass, almost no vibration, and theoretically unbelievable reliability. Think about what that meant for a moment. Every traditional engine relied on controlled explosions happening thousands of times per minute, metal parts reversing direction constantly, friction, heat, wear, oil breaking down, gaskets failing. A turbine just spun, constantly, smoothly, like a top that never stopped. The elegance was beautiful. But there was a problem. Actually, several. Turbines loved high RPM. Cars didn't. Jet engines worked best, screaming at insane rotational speeds while producing constant power. Cars needed low-end torque, throttle response, and drivability in traffic. A turbine also generated extreme heat. Exhaust temperatures could exceed 1,200 degrees Fahrenheit. Fuel economy was terrible at idle. And throttle lag? It could feel like stepping on the gas and waiting for permission from God. The engineering team faced challenges nobody in Detroit had ever dealt with before. Materials that could handle sustained exposure to temperatures that would melt conventional engine components. Bearings that could spin at speeds where traditional lubrication simply broke down. Aerodynamic designs for compressor and turbine blades that had to be machined to tolerances tighter than anything in automotive manufacturing. Still, Chrysler pushed forward. By 1954, they unveiled the CR1 turbine prototype. It was crude, inefficient, barely drivable, but it worked. Then came the CR2, then CR2A. Every version got more refined, more usable, more dangerous to traditional engine thinking. Each generation solved problems the previous one couldn't. Better materials reduced heat stress. Improved recuperator designs captured waste heat and fed it back into the system. Variable geometry in the turbine housing helped with throttle response. In 1956, a Chrysler Turbine Car hit 139 miles per hour at Chelsea Proving Grounds. And the craziest part? It could run on almost anything combustible. Diesel, kerosene, heating oil, unleaded gasoline, even tequila. No joke. Engineers reportedly demonstrated the engine running on perfume and peanut oil during testing. The turbine didn't care much about fuel chemistry because combustion happened continuously instead of through controlled explosions like a piston engine. One engineer filled the tank with Chanel No. 5 during a demonstration for executives. The car started immediately. Ran perfectly. The exhaust smelled like an expensive department store. Corporate leadership saw dollar signs, military contracts, international markets where fuel quality varied wildly, remote locations where gasoline wasn't readily available but kerosene was everywhere. Most people don't realize how revolutionary that was. Imagine America in the early 1960s. Gas stations everywhere. Muscle cars just beginning to explode in popularity. The Ford FE engines were growing bigger every year. Chevrolet was building monstrous 409s. Pontiac had the Super Duty 421. And Chrysler themselves were preparing the legendary 426 Hemi. Now imagine replacing all of it with a jet engine. Sounds impossible. But Chrysler nearly did it. In 1962, they made the biggest decision of the entire project. Instead of building another prototype, they were going public. Chrysler commissioned Italian design house Ghia to hand-build 55 production-quality turbine cars. These weren't rough engineering mules anymore. They were fully styled luxury coupes with bronze paint specifically chosen because it looked futuristic under sunlight. The design itself was pure 1960s optimism. Sharp angles, aggressive front end, sleek roofline, hidden headlights, chrome turbine wheels that referenced the engine spinning beneath the hood. The interior featured aircraft-inspired gauges with instruments that looked lifted straight from a Boeing cockpit. Everything about the car screamed tomorrow. Under the hood sat the fourth-generation Chrysler Turbine engine. Technically, it displaced almost nothing in the traditional sense because turbines don't use pistons. But internally, this engine was a masterpiece of airflow engineering. It used a two-stage gas turbine spinning up to 44,600 RPM. Power output was rated at 130 horsepower and around 425 lb-ft of torque. And before you laugh at that horsepower number, remember something important. Torque delivery was incredibly smooth. No vibration, no shifting shock, no camlope, just a seamless surge of power. The engine used a recuperator system to improve efficiency by recycling exhaust heat back into the intake air. That single innovation reduced exhaust temperatures from terrifying furnace levels to something barely manageable in civilian traffic. Cold air entered through the intake, got compressed, mixed with fuel in the combustion chamber where it burned continuously. Hot gases spun the turbine wheel, which drove both the compressor and the output shaft. Exhaust gases passed through the recuperator, heating incoming air before exiting. It was brilliant engineering that belonged in aerospace textbooks, not family sedans. And Chrysler needed every advantage they could get, because fuel economy was still ugly. During city driving, the turbine struggled badly. Idle consumption was terrible. The engine loved steady cruising, not stop-and-go traffic. At highway speed, it could deliver around 18 to 19 miles per gallon, respectable for the era. But in urban driving, it drank fuel like a thirsty drag car with dual hollies. And then there was the lag. Drivers would press the accelerator, wait, hear the turbine spool upward like a fighter jet preparing for takeoff. And then the power arrived. Early testers compared it to launching a propeller plane. You committed to acceleration before it actually happened. Throttle modulation required learning entirely new reflexes. Experienced drivers adapted quickly. Casual drivers found it unsettling. But Chrysler believed the public would forgive all of that because the experience felt unlike anything else on Earth. So they launched one of the boldest public experiments in automotive history. In October 1963, Chrysler handed the cars to ordinary American families. Not celebrities, not racing drivers, regular people. Over 200 families tested the turbine cars across 48 states. Each family kept the car for about 3 months before returning it. Chrysler gathered millions of miles of real-world data. Drivers filled out reports describing everything from reliability to public reaction. The selection process was intense. Chrysler wanted diverse geographic locations, different climates, various driving conditions, city commuters, rural farmers, families in scorching Arizona deserts and frozen Minnesota winters. And the public reaction was chaos. Crowds followed the cars at gas stations. People asked if it was nuclear-powered. Kids thought it was a spaceship. One driver reported strangers literally chasing the car down highways just to hear the sound. Gas station attendants would stop pumping fuel mid-fill just to stare. Police officers pulled drivers over not for violations, but to ask questions. Newspapers sent photographers to capture these bronze machines cruising through small-town America. One test family in Michigan reported causing a traffic jam because drivers slowed down to look. Another in Texas said they couldn't park anywhere without drawing crowds within minutes. A family in California was asked for autographs as if they were movie stars. The turbine cars became mobile celebrities, but behind the scenes, engineers were discovering problems that threatened the entire dream. The turbine engine produced massive heat under sustained load. Materials inside the hot section suffered thermal fatigue. Bearings faced extreme stress at rotational speeds traditional automotive engineers barely understood. Test data revealed turbine blade erosion after extended high-speed runs. Seals degraded faster than predicted. The recuperator, despite being brilliant in theory, proved expensive to manufacture and vulnerable to cracking under thermal cycling. And then the emissions issue appeared. Ironically, the turbine burned fuel incredibly clean in some ways. Hydrocarbon emissions were low. Carbon monoxide was reduced compared to many piston engines. But nitrogen oxides? Brutal. As combustion temperatures increased, NOx emissions skyrocketed. And by the mid-1960s, America was beginning to care about smog and air pollution in a serious way. California was already implementing stricter regulations. Federal standards were being drafted. Suddenly, the automotive industry faced a reality where emissions mattered as much as horsepower. What they discovered next changed everything. At the exact moment Chrysler was trying to perfect turbine technology, the federal government was tightening emissions regulations. The future suddenly wasn't about raw innovation anymore. It was about compliance, and turbines struggled badly under those new rules. Then came another nightmare: cost. Each Ghia-built turbine car reportedly cost over $50,000 to produce in 1963 dollars. That's well over $500,000 today. The hand-built bodies alone were expensive, but the real problem was manufacturing precision. Turbine blades operated under insane temperatures and speeds. Tiny imperfections could destroy the engine. Specialized alloys were required. Production methods became brutally expensive. Scaling production would require entirely new manufacturing infrastructure, specialized tooling, workforce training, quality control systems that didn't exist anywhere in Detroit. Meanwhile, piston engines kept improving. Ford's 427 side-oiler FEV8 was dominating NASCAR. Chevrolet's L72 427 was terrorizing drag strips with 425 horsepower. Chrysler's own 426 Hemi arrived with hemispherical combustion chambers, 12.5.1 compression, massive ports, and race-ready airflow straight from Daytona. The Hemi made 425 horsepower in street trim and well over 550 in race configuration. Quarter-mile times dropped into the low 12s. NASCAR speeds climbed past 180 miles per hour. And suddenly, America fell in love with something turbines couldn't deliver: violence. Muscle cars weren't smooth. They weren't quiet. They weren't futuristic. They were loud, angry, mechanical. You could feel every combustion pulse through the steering wheel. Every gear change hit like a punch to the chest. Big cams shook the entire car at idle. Open headers rattled windows. The turbine felt too refined, too civilized, too weird. Most people have no idea how much that mattered. Car culture isn't just engineering, it's emotion. It's identity. It's the sound your car makes when you fire it up on Saturday morning. It's the vibration through the seat when you crack the throttle. It's the theater of internal combustion, and emotionally, Americans wanted roaring V8 thunder. Not a jet-powered science experiment. Still, Chrysler refused to give up. By 1966, engineers were developing sixth-generation turbine systems with improved throttle response and better efficiency. They solved many early drivability issues using variable nozzle technology and upgraded recuperators. The newer engines accelerated faster and consumed less fuel. Engineers believed a mass-market version might finally be possible by the early 1970s. Internal memos showed optimism about reaching price parity with conventional V8s if production volumes increased. Advanced materials research promised solutions to durability concerns. Computer modeling suggested pathways to meeting upcoming emissions standards. And then the oil industry panicked. Well, maybe not officially, but rumors exploded that turbine engines could disrupt fuel infrastructure because they could burn almost anything combustible. Whether those fears were justified or not, political pressure around emissions and fuel economy kept mounting. Then came the final blow, the Clean Air Act era. New federal regulations demanded tighter emissions controls. Development costs exploded overnight. Chrysler itself was facing financial pressure. Insurance rates were crushing muscle car sales. Gas prices were beginning to rise, and the company made its decision. The turbine program was dead. Almost every car was destroyed. Out of roughly 55 Chrysler Turbine cars built, only 9 survived today. Most were crushed under supervision because import taxes and production agreements made it difficult to keep them legally. Chrysler didn't want unsupported experimental vehicles scattered across the country. The destruction happened methodically. Cars returned from testing were evaluated, stripped of valuable components, then crushed into unrecognizable scrap metal. Engineers watched machines they'd spent decades perfecting get fed into industrial crushers. Some reportedly walked away. Others took photographs as documentation of what might have been. Think about that for a second. One of the boldest engineering projects in automotive history, deliberately destroyed by its own creators. You can probably guess what happened next. The traditional muscle car era exploded. The late 1960s became a horsepower war unlike anything America had ever seen. The 426 Hemi, LS6 Chevelle, Boss 429, Ram Air Ivoud GTU, Buick Stage 1, Cobra Jet Mustangs. Massive V8s ruled the streets, while Chrysler's futuristic turbine quietly faded into myth. But here's the crazy part. Many modern automotive technologies accidentally proved Chrysler was thinking decades ahead of everyone else. Today's turbochargers spin at over 200,000 RPM. Ceramic coatings protect components from extreme heat. Hybrid systems use turbine-like power delivery characteristics. Multi-fuel military turbines exist right now. Even Chrysler's old problem with throttle lag, modern electronics solved that years ago. Imagine if they had another decade. Imagine a 1970 Dodge Challenger powered by a refined 300 horsepower turbine engine screaming at 60,000 RPM. No vibration, no valve train, no piston failures. Just endless smooth power and the sound of a fighter jet tearing through downtown Detroit. Muscle car history might have looked completely different. No camshaft wars, no giant displacement arms race. Maybe no fuel crisis collapse the same way. Maybe America becomes the world leader in turbine-powered transportation instead of abandoning it completely. Picture showrooms in 1972 filled with turbine-powered Roadrunners, Chargers, and Barracudas. Drag strips echoing with high-pitched screams instead of V8 thunder. An entire generation of mechanics trained on aerodynamics and thermodynamics instead of carburetor tuning. We'll never know, because the Chrysler Turbine Car wasn't killed by one single failure. It died from timing. The technology arrived too early. The world changed too fast. Regulations tightened before engineers could finish solving the problems. And emotionally, the market chose thunder over science fiction. Corporate priorities shifted. Investment money dried up. The team disbanded. George Hubner retired, watching his life's work vanish into automotive history as a fascinating footnote rather than a revolution. But that's what makes this story so fascinating. The Chrysler Turbine Car wasn't just another experimental concept. It was a genuine fork in automotive history. A moment where Detroit almost abandoned pistons entirely and chased something radically different. And for a few brief years, it actually worked. That turbine engine didn't just run. It drove across America. It survived millions of test miles. It proved jet-powered transportation was possible for ordinary people decades before most companies could even imagine it. And maybe that's why people still talk about it today. Not because it succeeded, but because it came terrifyingly close. If you enjoyed this story, let me know what engine or forgotten piece of automotive history you want to see next. And make sure to subscribe, because some of the wildest stories in car history aren't the ones that won. They're the ones that almost changed everything.